Okay guys, so in this video I would like to discuss linear independence and how it actually works with a system of linear equations, namely 2 or 3 for the basic example. So I wrote that the equations of a linear system are actually independent if none of the equations can be derived algebraically from others. So in this case, every equation has to be a unique equation. Also, when the equations are independent, each equation contains new information about the variables, and removing any equations increases the size of the solution set. So yeah, I mean, what I'm saying here is that pretty much, just like the first point, is that each equation should have something new about it. So shouldn't it be, again, a derivative of the first one, or at least a form of the previous. Finally, for linear equations, logical independence is the same as linear independence. Yeah, so again, I'm just pretty much restating the facts here. Now, I presented an example here, so I've got one of two examples. The second example is a complicated one, but easy anyway. So for this linear examples, I stated that 3x plus 2y equals 6 and 6x plus 4y equals 12 are not linear independent. This is because if you can clearly see, we can see that 6x plus 4y equals 12 is exactly 2 times bigger than this. So in fact, this is pretty much a combination of this. It's just a scale factor of 2. So it's not actually a unique equation. That is the main thing about this. We also can see that they would produce identical graphs. Just one is just exactly identical graphs. So there is nothing independent about it. So this is what I call an example of equivalence in a system with linear equations. Yeah, pretty cool, man. Not bad too, guys. Now, example number 2. Let's check this one out. So we got 3 equations. So we have x minus 2y equals negative 1, 3x plus 5y equals 8, and 4x plus 3y equals 7. Are they independent? No. How do we know this? It's because that the third equation here is actually the sum of the previous 2. And I mean, another way to really understand this as well is that when you actually solve this, you're going to realize that you're going to get only one point of intersection, usually. Only a single point section. That is because the sum of these two equations will somehow intersect at the same point. So you will not get two unique solutions or 3 unique solutions. You will only get one. And this is how it looks like. Voila. So one unique solution. And that is because when you're accumulating these two graphs to make the third graph, you're going to get 1. So again, this equation is not a unique solution. Even though these two are, x minus 2y and 3x plus y are unique, because this one, the first one, isn't unique, then you ain't going to get a solution. So yeah, that's really the sum of it. This is just a basic understanding of linear dependence. And yeah, so the whole purpose is to rewrite the equation in a way that does not form. If I change 4x plus 3y into 5x plus 3y, what happens here exactly? Well, you're going to get an equation that is in fact linear independent. And I can let you guys show you why. Bottom line is all these equations will give a separate solution. And yeah, that's it for now. Or actually, it might not give any solutions. I never tested it, but you'll need to solve this and see where these lines cross. Or you can draw these lines and see how it looks like graphically. But yeah, other than that, I hope this video helped on a basic understanding of linear independence. And let me know if you've got any more questions. Other than that, I shall see you guys down the road. Ciao.